some discussion if you have interest about the presentation in the morning. Yeah, oh, please.
So it seems like the lower mantle also has a situation where you have a strong mineral, perovskite, and then a weak mineral that's around 20 or 30%, which is magnesiowustite. I was wondering if the results that Sean showed this morning could be applied to that, to the lower mantle.
Yeah, I think, I don't think we have any data, but I think that's a possibility because 20,000%. It's very close to operating threshold. So once technology is there, yeah, we are developing high pressure apparatus. Lower mantle is 24 GPa, now it's 23, so 1 more GPa. Next month, okay, we have a this. So then it's a localization, and then it's the commercial production.
Okay, thank you very much. I have a question about Dr. Li Jun. And you showed the segment slab, and the CT is about 140 kilometers, plus minus 40 kilometers. You mean there's some little variation in the thickness in different regions? Oh, that's a certainty. Yes. Okay, I see. And how about the location of the western edge of the segment slab? Can you consider that?
According to the retest space and the recovery in my map, I think I can see that the western wedge located around roughly around 120 to 150 degrees. Yeah, region or just a little western. Yeah, a little western to Beijing.
Any other questions, comments about the presentation in the morning? Okay.
For your models.
Who's model? Mine?
Yeah. What depth was the tomography crop that you showed where you had tomography and the sites of the Tohoku earthquake ruptures? It wasn't clear what the depth was for the tomography. The map view.
Map view. That's for the 50 kilometer, 60 kilometers.
60.
Yeah. But the model itself will have down to 200 kilometers. Yeah. But the depth range of the seismic in the zone is about 50 kilometers. Yeah. So the depth is 60 kilometers, but the horizontal range from the Japan trench is about 200 kilometers wide. Okay. So the rupture zone is 200 kilometers times 500 kilometers, north-south direction.
Do you get these surface effects? Is there a certain near the surface you have near the surface in the tomography model that you have to remove the upper part, or I mean, what depth does your tomography model end towards the surface?
A trench. Yeah, I mean in the trench area, you can go to the trench, but of course in the island part, you go to the surface, the model. Yes. Yes.
I have a question for you.
Okay.
In your BMW model there, BMW model,
yes.
English, I caught a glance that to create the volcano, essentially you have what you call a hot and wet environment. Yeah. And a little I know about petrology of volcanoes. I always tell my students there are two models for volcanoes: hot volcanism and the cold volcanism, which is due to water. And so, in your model, what kind of product would you expect? What kind of volcanic rock would you expect? And is it what is observed?
It's a basalt.
It's a basalt.
Yeah, alkali basalt. But let me answer your first question about that. The reason I mentioned that because some electrical conductivity studies show the mantle in East Asia is wet. It's a high conductivity. Okay. By TT another 2006. Also someone mentioned that.
But beyond the end product, the volcanism which will be generated is going to be hot volcanism, basaltite.
Yes, and yeah, last few years.
Because it's deep, it's alkali, it's strong alkali.
Right. And in the last few years, several groups have done geochemical and geological studies for those rocks.
Yeah.
And all the results support my model, the BMW model.
Right.
So it should be okay.
So it's BMW, it's not Mercedes.
Not a car. Okay. Still not ready yet? Okay, we have to continue this discussion. Any other comments, questions? Yes. Okay, thank you very much.
Only you remotely model just offshore area. You just showed us peer velocity model, so some very high demonstrate anomaly and lowest anomaly. So, but your conclusion is that structural heterogeneity will be important to generate to explain such generations. So, but yeah, they are just VP they are just not a structure, just sort of physical properties. So what kind of structure difference between rock area and non-rock area about the area to explain the subdivisions?
Okay. That's a very good question. I think let me simply repeat the question. Is what's the nature of the anomaly, right? What's the geology for that part? Is that your question, I guess? Okay. It's a very good point. And what we observe is only POS with velocity variation. Okay. I think the low velocity anomalies may reflect the softer material with the subducting sediments or contain fluids from the slab deposition. But the high velocity blue zones may represent the subducting seamounts or topography heights, or some yeah, something like that maybe, or maybe composition variation, maybe some hard rocks. But of course, we still need other information for the nature of the heterogeneity. Yeah. But at least we think the topography reflects the structural heterogeneity.
In a sense, the upper plate and the downer plate is quite important. Which one is better, more important for you? Downer plate. Incoming plate. Downward plate. Okay.
Yeah. That is the Pacific Ocean flow. That's a fact law. Pacific plate, yes. Okay, great.